Yeah, hi. My name is Justus Ndukaife. I'm a professor in the Department of Electrical and Computer Engineering. Welcome you to our lab, and I'd like to show you what we do. So even though we are engineers, we conduct interdisciplinary research. So our lab has two sections. This is the chemistry section, where we prepare our chemical samples like biological materials and nanoparticle solutions. And then after those preparations, we then go into the optics room where we do the optical experiments. So let's hover over to the optics room. So here in the optics room, we built several custom optical microscopes, which we use to analyze very small biological objects. So why are we interested in this? One of the tools that we built are something called optical nanotweezers. And the interest in this is because the conventional optical tweezer technology, which was awarded the Nobel Prize in Physics back in 2018, they are unable to be used for manipulating things that are below cellular scales. So they're already very useful for things on the cellular scales. But of interest to us is to probe much smaller biological objects that cells release, such as extracellular particles and extracellular vesicles. So these very small particles are way much smaller than the wavelength of light. So we need to develop a new ways to be able to handle them and manipulate them so that we can better study them and address important fundamental biology questions in the field. So here we have some microscope that we've set up. So this system here can do both optical trapping, fluorescence imaging, dark field imaging, as well as Raman spectroscopy, for instance. So what we do is we use the clean room facility to design and fabricate our devices after designing them. So we build different kinds of optically resonant nanostructures and metasurfaces and nanoantennas that enable us to manipulate light on the nanoscale. So after preparing the chips in the clean room, we package them here, building some microfluidic networks around them, and then we characterize them on a microscope and use them to perform our analysis, like trapping our biological objects and doing a subsequent analysis on them.